Here, we're focusing on how we can represent physical and chemical changes and understand or classify them as one or the other. When we have rubbing alcohol and it's evaporating, that actually evaporates very quickly, much more quickly than water. And we want to think, is this change chemical or physical, with an explanation? So the change is physical, evaporation, whether we're talking about something that we define normally as a chemical like ammonia or ethanol, or we're talking about water, it is still just the change of phase or state of matter from liquid to gas. So that does not change the chemical composition. So we really need to know those 6 names for the common changes of state: melting versus freezing, boiling or evaporating versus condensing. And then the more kind of extreme ones, the solid to gas is subliming, and gas back to solid is deposition. In all of those, it's talking about a pure substance that's not changing what it is. Here we look at hair being bleached, in which its colors changed. And once upon a time, that was something that I did. Or water can be dyed. Both of those are changes in color, but one is chemical and the other is physical. So as we think about this, bleaching hair is a chemical change. It's actually changing the composition of the hair. There is a chemical reaction occurring where we're changing those molecules that are giving your hair the color, the melanin. That makes something different than what we started with. And although we can continue to dye it, it's not easily reversible without some sort of kind of extreme other change. Dyeing water is physical because the food coloring or the dye and the water mix together, but we're not really making a new chemical. We're not breaking apart the H2 and O, and we're not breaking apart all of the atoms within the dye either. They just spread out, they attract with the interparticle or intermolecular forces, while the structure of the water and the structure of the dye remains the same. So to kind of clarify how we can show this in some different ways, we can write equations related to any physical or chemical change, where we represent what we're starting with, we represent what we're ending with, and we try to be as clear as possible, either with words or with chemical formulas when possible. So right here, liquid water evaporates into steam or into water vapor, liquid to gas. And in doing that, it's still balanced, and we still make sure that we have all of the right formulas and the right numbers. But when water breaks down or decomposes into hydrogen and oxygen, they are breaking apart. That's a chemical change. H2O liquid becomes hydrogen gas and oxygen gas. And we remember that hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are diatomic, which is why the formulas are like this. And then I have a 2 as a coefficient in front of some of my chemicals so that the total number of hydrogens on the left and right and the total number of oxygens on the left and right are equal or balanced, proving or supporting the law of conservation, of matter and mass.